Now we are going to understand thermal energy transfer. Okay. Now thermal energy is basically the heat energy. Or no, I won't say it's exactly heat energy. It's basically energy possessed by an object which comes in form of heat. Okay.
Okay.
So when thermal energy transfers from one point to other point, it's called heat transfer.
Okay.
Yeah. So thermal energy is the object, the energy associated with the object which actually varies its temperature. Okay. So we are measuring temperature of an object, isn't it? Yes, we are measuring a temperature.
Yeah.
Right? That temperature is actually associated with the thermal energy of the object. Okay.
Okay.
In this particular concept, we are going to discuss about thermal energy transfer, black body radiation, solar constant, albedo, energy balance, greenhouse effect, and mechanism of photon absorption. Okay. So first thing, when I talk about thermal energy transfer, there are three ways how thermal energy can transfer from one body to other body: conduction, convection, thermal radiation. Heat flowing through a conductor or solid is called conduction. Understood?
Okay.
In conduction, the vibrations are passed. Like if I have some conductor like this pencil. Pencil is not a conductor, but I'm just saying we have a metal pencil. If I heat from this heat, if I supply heat from this side, thermal energy goes like this, like this, like this, and
Yeah.
so when you're holding it here, you feel that heat, isn't it?
Mm.
Feel the heat, right? So
Yes, sir.
this is called conduction. Okay, so flowing
Okay.
of heat energy or flowing of thermal energy in the form in a conductor, in a solid, it's called conductor. There are different types of
Okay.
conductor: good conductor, bad conductor, insulator. Good conductors are conductors in which conduction happens very fast, such as metals, because they have free electrons. Bad conductors are the conductors in which the conduction happens very slow. Plastic, rubber, all these are bad conductors. And insulators are the things which do not pass heat, such as air. Air is only
Okay.
heat. All these things are bad conductors. Metals are good conductors. Okay.
Yeah.
So here there's a formula that you can make a note of. Delta Q by delta T is Ka into delta T by L, where A is the cross-sectional area, L is the temperature, and length is L. Temperature difference between the end is delta T. Okay.
Yes, yes. It's writing it down.
And K is called conductivity.
Okay.
Okay, fine, great. All right, let's move forward. So this is basically tells you the rate of conduction. Okay, for conduction, this formula is for conduction. Next is called convection. The next form of heat transfer is called convection. And convection, say basically in solid, matter does not move, only the energy moves. Okay, because matter is vibrating, atoms are vibrating, but atoms are not moving. Only the energy is moving. But in this case, the matter itself starts to move. Okay, convection
Okay.
takes place in convection. Correct? How you know? It is told that hot water is less denser and cold water is more denser. Okay. Now imagine you are heating a cup of water. Okay, you're heating water. Okay. When you
Okay.
water, hot water is developed here, isn't it?
Yeah.
Okay, hot water is developed. This hot water rises up because hot water are less dense, and from here the cold water comes down, isn't it? And this
Yes.
water becomes hot again. Okay. Now
Okay.
this is called convection cycle, and this is called convection. Okay. Convection
Yeah.
happens in fluid, not in solid. Because in solid, the particles are rigid, they cannot move. But for convection, the particles are supposed to move. Okay, so particles
Okay.
move or flow in a fluid, either a gas or a liquid. Okay, this is how
Okay.
convection happens. The last one is radiation. Radiation is transfer of heat with the help of electromagnetic waves.
This doesn't require any medium, right?
It does not require any medium. So that is how the energy from sun reaches us. Okay,
Okay.
heat energy from the sun reaches us, and that event is called as radiation. Is that clear to you?
Yeah.
Okay. Now, all right. So now you understood the three types of energy transfer, isn't it?
Yes.
Okay. Now let us try to understand black body radiation. Okay.
Okay.
So basically, this black body radiation is kind of a heavy concept, but they have given only a very small portion of information about it. You know, black colors have an advantage in radiation. What is that?
Black color, they absorb all the light.
Exactly. Black color absorb all the light. So, there's a black body. Okay.
Mm.
Through this black body, there is a small opening through which light can come. And there is a mirror which can deflect the light in all direction. Now just imagine if the light is coming, okay? Light is coming in, and this light gets reflected and gets multiple reflected. That means it gets trapped inside the black body, isn't it?
Yeah.
This light gets trapped inside the black body, and the black body absorbs all the light that is coming. Okay, the black body
Okay.
absorbs all the light that is coming. All right, and that is
All
how
right.
the light is absorbed inside a black body, because a black body, a body which is black, can absorb all the radiation from all. Okay, so
Okay.
this is the specialty of a black body. Okay,
Okay.
now black body radiation is when you heat the black body now. Okay,
Mm.
when you heat the black body, it starts emitting all the light which was absorbed outside. So initially I showed you how the light is getting absorbed. There is black body absorption.
Mm.
Now when you take that black body, open that black body and heat it will radiate the light which was absorbed. And that's called black body.
Okay.
That's called black body radiation. And
So radiate all the light.
yeah, it will radiate, since it has absorbed the light of all the radiation, it will emit the light of all the radiation. Okay,
Okay.
and the power of radiation generated is given by Stefan Boltzmann's law, and that is the energy per second radiated by a body depends on the surface area and the absolute temperature of the surface, and E into sigma, that is
Sigma 80 power 4.
sigma is the
Stephen Boltzmann constant.
constant. Okay, and E is 1. Basically, E is 1 in this case. So we will just write P is equal to sigma A T power 4. It's called
Okay.
black body radiation. E is called the emissivity. Emissivity of black body radiation is always taken as 1. Okay. Now consider the body of emissivity E and T, temperature T, whose surrounding is temperature Ts and may be assumed to be black body. The body radiates in the rate of this and absorbs the rate of this. The rate net rate at which energy leaves the body is this. Net rate. Why are we taking in consideration net rate? Because when a black body is in really present, when you heat it, it is emitting radiation. Also, it is absorbing. So net radiation emitted is emitted minus absorbed. So
Okay.
net radiation leaving the energy, so leaving the body. That means net radiation leaving the body is emitted minus absorbed. So Ts is the temperature of surrounding. Okay, so this is
Okay.
the energy emitted. All right. At equilibrium, no net power leaves it. Okay, at equilibrium, at a certain temperature, no net body leaves. So it has been observed that when light emits, see, yeah, I will show you the before you understand this formula, Wien's law, I will tell you what is this. Wien's displacement law. See, you see in a black body. Look at the black body. I'll show you something. This is a black body emission for 3 different temperatures. Same black body, but heated at three different temperatures. Understood? Same body heated at 3 different temperatures. Now observe here what is happening. You see that for a lower temperature, your lambda value is kind of here. For higher temperature, lambda value goes like this. And for much more higher temperature, your lambda value is decreasing. So technically, your lambda value is decreasing as your temperature is increasing.
Temperature is increasing. Yeah.
And that means your lambda value is decreasing. That means your frequency is increasing. Okay. That means at a higher temperature, the light emitted will be of higher frequency, isn't it?
Yeah.
Higher temperature corresponds to higher frequency. This is called Wien's displacement law. Okay?
Okay.
Called Wien's displacement law, and that is the law which is explained here with the help of a formula. See, lambda max T 2.90 and 10 power minus Wien's displacement law. Okay.
Okay.
Great. So now you understood how the black body radiation works.
Yeah.
Now